speed of sound, people think goes quite quickly. Now, for many years I've studied this phenomena, the movement of sound and the speed it travels at. I know it from back to front. It's a subject I know very, very well. It travels at roughly a good scientist always refers back to the notes anyway. It travels at precisely 343 ms, which is millimeters per second. Like you got 60 seconds in a minute, so it's which works out at roughly, I know this, hold on a second, 767 mile an hour, which in kilometers is a lot more than that. I'm going to give you an example of a sound, and you just see how quickly this moves. It's faster than you think. You ready for it? Are you ready for it? Yeah, okay, well, ready? Dry lips. There you go. So how long did that sound take to get to your ears? Makes you think. The sound I just made travels pretty quickly, and that can be measured. Throughout the course of this experiment today, I'll be showing you how to measure it and actually establish how quickly sound travels. You will see that it travels significantly faster than 760 odd mile an hour. Light!
Are we doing sound?
Yes.
It's on. It's on.
It's on. Oh, sound. It travels very quickly, a lot quicker than you think. Sound. 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 So sound, how fast does it really travel? Well, that's a really good question. Some people think it's quite fast. They think it's about 760 odd miles an hour. Or is it? Sometimes it travels at 340 odd meters per second. And that, folks, is many, many, many kilometers an hour. Or does it travel at that speed? I suspect it travels a lot faster, as you'll see in these upcoming experiments, where we travel and speak to other people. It's at that point of the experiment where I need to enlist the help of another colleague, and that's the illustrious Dr.L. Arling, Lovelee darling. So with satellite technology now, we're going to get patched through to Dr. Arling. Lovelee? Through the miracles of modern science, we're going to go across the pond and river to talk to Dr. L. Arling. He's in Utah as we speak, just outside Cornwall. Okay, through satellite now, we're going to go through to Dr. Lovelee Arling. So Lovelee, Dr. Lovelee, are you there? He might be there. Hold on, still getting interference. Lovelee? Great. Okay, Lovelee, if you could now continue with the experiment. Thank you.
Okay.
As soon as Dr. Arling, or Lovelee as he's known, will start playing, we're going to measure the sound time. Okay, thanks. So you can see from the moment I asked Dr. Arling to start playing his instrument, the sound in its entirety took about 47.6 seconds, and that includes me trying to stop the experiment when I needed to. Until this point now, it took roughly 4 to 20 seconds before the sound got to us, and that's in Utah, outside Cornwall. And that shows you something, eh? Okay, getting into science again. So I don't know if you can see this. I'm going to tap this and time the sound when it actually, well, I'll record it here, okay? So you listen with your ears. And now. Okay, I'll try that again. That was 1.4. Okay, let's try that again. About 0.73 seconds to travel this distance, probably about a second or thereabouts. Okay, so for my next experiment, I'm going to phone my wife, she's Australian, but she's in the kitchen, and we'll see how long it takes for her to respond to this phone call. So hold on a second. It's ringing.
Are you phoning me?
Pardon?
Are you phoning me?
Oh, yes. Why aren't you picking up?
My phone's in the kitchen.
Okay. Okay, for the next experiment, I'm going to get my wife just to...
Too loud.
What?
Too loud. Too loud.
Oh, sorry. I'm going to get my wife to tap a top hat cymbal, and I'm going to time it, see how long it takes for the sound to travel, and whether or not I can hear it with this. So it might work. There you have a watch. Okay, I'm just going to set up the watch, the stopwatch. Okay, and now. Now.
You want me to hit it now?
Okay. Pardon?
On 3?
What?
You want me to tap?
What,
On
3
3.
times?
On the count of 3.
On the count 3. Yeah, okay. Oh, I got to count 3. Okay, right. Okay. 1, 2, 3. Now that's quite interesting. If you look at the timing there, that's 0.62. This one was 0.7 something or other. And it took less time for the sound to travel a greater distance from that cymbal to the phone here as it did from the bass drum on the floor down over there. So that just shows you through a longer distance, as we found out from Dr. Lovelee Arling earlier, that it doesn't, given the distance, it doesn't take that, it's a short distance, therefore takes longer to get to you. Long distance, it seems to travel at a pretty good rate towards you. So I don't think it's 767 miles an hour. I think it's a lot faster than that. Okay. Sound. You can hear it with your ears, and you see me with your eyes. Sound goes faster than you think, and also I would suspect it goes a lot faster than you can walk.